Hi there, I'm going to show you a quick experiment that you could do or get your learners to do during British Science Week. And this is a really simple, straightforward enzyme experiment, and it's really great because it shows that enzymes are found in living things, even something like a banana. Okay, so you just need a few wee things. So we've got a test tube rack and a test tube. You're going to need some water. The substrate for this reaction is L-dopa. So this was the L-dopa powder, and I just dissolved it in water. A fork, and then a beaker or a cup, and a pipette. So I'm just going to start by taking just a really small amount of the banana, so probably about that much. And then you're just going to mash it up. And then just keep adding water to that, so you don't want it to be too, you can have it quite liquidy. And you're going to have to be able to use a pipette to extract some of the liquid from this. And if it's too gloopy, it doesn't work very well. So add a decent amount. Further up the school, you might use a centrifuge and just get the actual liquid portion of this. But actually, this works fine, as you'll see. So I think that's okay. So you can maybe see how runny that is. It could probably be a little bit more, just to help pipette it. So just give it a good swirl around, and that's it. And then into your test tube, just take a small pipette, and this is the substrate, so this is the L-dopa. And depending on the volumes that you want to use, or however much you've got, you could get away with 1 ml, 6 ml. It's not a particularly fussy recipe, this one. So that's your substrate in. And then we'll get a clean pipette, and you've got to now extract some of the banana liquidy stuff. So if you had centrifuge this, you would have the supernatant, and that contains the dopa oxidase enzyme. But when it's like this, you'll find it's quite difficult to pipette. So just go to the edge and try and extract some without getting bits of banana in it. So I've got a wee bit there. Again, it's not particularly fussy. And then, so this is the substrate in the test tube, and this is the enzyme in the pipette. And you can see it's completely clear. And as we add that enzyme in, very quickly, it's going to change colour, because we're going to have a reaction that produces the product dopachrome. And dopachrome is something that, as we said right at the beginning, is involved in making your hair red. So I probably have quite a bit of this. And you'll see quite quickly, it's really good if you hold up against a white background. We put it here. So within about 20 seconds, you can see that there's quite a lot of dopachrome being formed. And this reaction here is part of a wider range of metabolic processes. And students could do this reaction as part of understanding why people have red hair. They could talk about it in terms of the production of melanin, and therefore different colours of skin. They could talk about it in terms of the production of dopamine, and therefore think about Parkinson's disease and how that process might happen. And they could also talk about it in terms of genetic inborn errors of metabolism and the involvement of this pathway in PKU. So there's lots and lots of ways, just from a simple experiment, to see that actually there's something in that banana, the same as all of our cells, that has taken this colourless substrate and it's turned it into a new product, dopachrome. You could also go on a little bit further and look at how there's different materials that can actually affect the rate of that reaction. So this took about 20 seconds for this product to form. But there's lots of research that shows that green tea can inhibit this and make this reaction go slower. So you could maybe do the same reaction with a bit of green tea in there and see if do you get the red stuff quite so quick. So anyway, I hope your pupils have fun doing enzyme experiments with bananas.